I want to go through the Module 3 exam. A number of you seemed to struggle with it, but I think a lot of it is you were rushing through the test or you were using the incorrect information. Because it's so important that you take your time reading the questions and pay attention to the instructions. One of the things that I tried to do to help you was, guys, there were headers here. It clearly has the header here that says Z interval, which is a huge clue, or at least should have been a huge clue that that's what you should do. Okay, so we read the question, and it says, the president of GHC wants to know the average hours Math 1401 students are employed. He wants a range for these hours. Assume the population standard deviation is 24.26. The sample mean for the 205 randomly selected GHC students is spring 2020 is 25.50 hours, and the sample standard deviation is 26.40 hours. Construct a 95% confidence interval for the hours of employment per week. Now, most of you got the question 1 correct, where you had to match everything. Okay, so if you go back and look, the value 2640 is the sample standard deviation. It clearly says the sample standard deviation is. So that's number 2. 205 was my sample size. 2426 was the population standard deviation. My confidence level was 95%, and the sample mean was given as 25.5. And so I need to construct that. And guys, I even gave you the link to the website. Okay, it says, the question says, what is the lower bound for that particular interval? Okay, for a 95% confidence interval. And again, the header clearly said it was a Z interval. I provided the link. You didn't even have to go into D2L to look for it. If you click on this link, and I'm going to open it in a new tab, it takes you to the confidence interval calculator for the Z statistic. So I'm going to scroll down. But guys, here's where a lot of you are made a mistake. The sample mean was 25.50. The sample size was 205. The standard deviation, guys, this is a Z interval, and I know the population standard deviation. If you know the population standard deviation, you're supposed to use it. So the population standard deviation was 24.26. The information that the sample standard deviation was 26.40 is just extra information that you do not need to work this problem. So I enter the correct information. The sample mean is 25.5. Sample size is 205. The population standard deviation is 24.26 at the 95% confidence level, and we calculate. When I scroll down to the bottom in blue, I get the lower bound, which is 22.179, the upper bound, which is 28.821, and remember the number on the last slide in the box here on the right-hand side is going to be your error bound margin. Okay, so all the numbers are given to you. So then we got to go and select them. Okay, so my lower bound was 22.179. My upper bound was 28.821. And my error bound margin was 3.321. Then the last step is you have to write the final conclusion. The biggest thing about writing the final conclusion, you got to make sure you get the right set of numbers. So I need the set of numbers 22.179, to 28.821. Okay, so the other thing, and there's two of those that have those numbers. Guys, the other phrase, and I remember emphasizing this in one of the lessons that we talked about since we resumed class, is that you have to have the phrase true population mean in the statement of your final conclusion. So the answer here would be the last one. We estimate with 95% confidence that the true population mean number of hours GHC students are employed per week is 22.179 hours and 28.821 hours. All right, then we move on to the second question. Again, clearly labeled Z interval 2, which means it's the second problem that's a Z interval. So again, it's clearly labeled as a Z interval. If you take the time to pay attention, I tried to make it as simple and as easy as possible for you in this format. It reads, the director of marketing and communications at Georgia Highlands College wants to target advertising to the appropriate age range. She randomly selects 326 GHC students whose mean age is 23.368 with a sample standard deviation of 6.815. Assume the population standard deviation for the age of GHC students is 6.95. Construct a 95% confidence interval. Okay, so again, one of the things I noticed, I've got the yawns, assume the population standard deviation is 6.95. Guys, if you have the population standard deviation, you have to use it. And again, it was clearly labeled as a Z interval, which means I need that piece of information. So again, using the question and marking and connecting and matching all these up, 326 was my sample size. 6.950 was the population standard deviation. 6.851 was the sample standard deviation. 99% was the confidence level, and 23.368 was the sample mean. Now, again, when you get to question 7, it asks you what is the lower bound for the 99% confidence level, and I give you the link to the website. Okay, all you had to do was click on it, and it would take you to the website. And I go out and I put in the information. I really don't know how I could have made it any easier for you guys. So we put in the sample mean, which was given to us as 23.368. My sample size was 326. The standard deviation, again, this is a Z interval. You should be using the population standard deviation, which was given to you at 6.95. We're doing a 99% confidence interval. Calculate. Again, the calculator does all the work for you. We get 22.3765 and 24.3595 for our upper bound. Remember that your error bound margin is on the left-hand side at the very last line. It's 0.9915. Okay, so I would write down those things on my piece of paper, go back to the quiz. So my lower bound was 22.3765. The upper bound was 24.3595. My error bound margin was 0.9915. And again, as you go down to make the final conclusion, you want to make sure you got the right numbers, 22.3765 and 24.3595. And you have those in 3 of the 4. Okay, and again, the thing you have to remember is you got to have that phrase, true population mean. So it's the second one. Then as we move to the third grouping of questions, again, guys, please pay attention. It's clearly labeled as a T interval. Okay, so it reads, the registrar for Georgia Highlands College wants to know a range for the mean number of hours earned by GHC students. He randomly samples 326 GHC students and determines the mean number of hours earned is 36.47 hours with a sample standard deviation of 25.05 hours. The population standard deviation is not known. The scenario clearly tells you you don't know the population standard deviation, which means you have to do a T interval. Construct a 95% confidence interval for the mean number of hours earned by GHC students. Okay, now I will admit I did have an error on the answer for question 11, but I have gone through every student's test and given you credit if it was correct. I had some of the matching numbers incorrect. Okay, but if you look at this, 25.05 was your sample standard deviation. Unknown was the population standard deviation. I have that highlighted in blue. 95% is your confidence level. 326 was your sample size. And 36.41 was the sample mean. Okay, then you continue to question 12, and again, it asks you to calculate the lower bound. And again, guys, I give you the link. You didn't have to go looking for it in D2L. If you'll click on it and open it up in a new tab, okay, this one just says single sample calculator, interval calculator. There's a little T right here, and so that helps me realize, yeah, I'm dealing with T. Again, you enter the sample mean, which was given to you in the problem as 36.47. The sample size was 326. In this case, you have to use the sample standard deviation because you don't know the population standard deviation. And if you don't know it, you can't use it. So my sample standard deviation is 25.04. And we wanted a 95% confidence interval. So I've entered my numbers and I'm going to calculate. And I scroll back down. My lower bound is 33.7417. My upper bound is 39.1983. And remember, the number here on the last line on the right-hand side is your error bound margin, 2.7283. Okay, so we write all those things down. We go back to our quiz and we select the answers. Okay, so my lower bound was 33.7417. My upper bound was 39.1983. My error bound margin was 2.7283. And then again, we go to our final conclusion, and our final conclusion needs to have those numbers, 33.7417, 39.1983. Okay, so we've got 3 options here with those. Well, actually, looks like all the options have those numbers, so we've got to make sure we get it right. We need true population mean, so that narrows it down to the first 2. So let's see, we estimate with 95% confidence that the true population mean hours earned by GHC students is between 33.7417 hours. Okay, the second one says with 5% confidence. So it wasn't 5%, it was 95. Then we move on to the next grouping of questions. And again, if you pay attention, guys, to the header, it clearly says T interval 2. Okay. And it says, the president of Georgia Highlands College wants to know the mean overall GPA for enrolled students. He would like to have a range of GPAs. He surveys 200 students, randomly selected GHC students. Overall, the mean overall GPA is 2.9278 with a sample standard deviation of 0.8641. The population standard deviation is unknown, and it wants us to construct a 99% interval. Again, with question 16, I did have some errors on the matching, so I went back and corrected that on your test papers. Okay, so matching 200 was my sample size. Unknown, it clearly said my population standard deviation was unknown. Confidence level was 99%. 2.9278 was the sample mean. 0.8641 was my sample standard deviation. So then it asked me, what is the lower bound? And again, it gives you the website link. So all you had to do was click on it. And it's thinking about it. And it comes up. And I scroll down. And I have to enter the information. The sample mean given in the problem is 2.9278. My sample size was 200. My sample standard deviation, which I have to use because I do not know the population standard deviation, is 0.8641, and I want to do a 99% confidence level. And I calculate. And I scroll down, and I have my lower bound is 2.768891. My upper bound is 3.086709. My error bound margin is 158909. Again, remember that's on this last line on the right-hand side. So I write my answers down, and I go back to my test paper, or to the test. My lower bound was 2.768891. My upper bound was 3.086709. My error bound margin was 1.58909. And again, we come to the conclusion, and we need to make sure we get the right numbers. So I need the 2.768891 and the 3.08709. So that's in the first one, the second one, and the third one. We're doing 99% confidence, and we need to make sure that it says true population mean. So it's the second one. Then we shift gears. The very last question, or one of the last questions, says one mean z-test. Guys, we only talked about the one mean z-test when we were talking about hypothesis testing. Now, initially we had planned to talk about the t-test, but because of the delay, the 2-week suspension, we omitted it. So we only talked about the one mean z-test, and again, it's clearly labeled for you here in this problem. So this problem reads, it is believed that the average age of GHC students is 24. Using a 0.05 level of significance, should the findings of the class survey support the belief that the average age is 24? The sample mean age for 50 randomly selected GHC students is 22.92. Assume the population standard deviation is 6.5. And then it says, which test should you conduct? Guys, it should have been a dead giveaway. First of all, the header reads one mean z-test, not to mention that was the only one that we talked about. Then you need to match the pieces together. 50 was my sample size. 22.92 was my sample mean. 6.5 was the population standard deviation. 24 was the population mean, and the level of significance was 0.05. And then it begins asking you the questions like, what is the null hypothesis, and so forth. So I'm going to copy this question over into Word so that we can kind of walk through it together. Okay, so we're to the point where we're ready to state our hypotheses. And so the first sentence says, it is believed that the average age of GHC students is 24. Guys, that's the claim. That's what we believe. Even in the second sentence, it says, should the findings support the belief that, remember, we look for words like belief, claim, think. Okay, so we need to think through this process here. Okay, so I have H sub O, which is my null hypothesis, H sub A, which is the alternative. Is, I hope the word is makes you think of equal. Since that's equal, this statement is my null hypothesis. So we would have the mean is 24, and that's the original claim. Then I have to figure out what the alternative is. Okay, so the mean is not 24, because remember they are exact opposites. So if we wanted to, at that point, we can go back to the quiz, and we know that we're doing a one mean z-test. We've matched all of our information. The null hypothesis always and forever contains equal. So it has to be the mean equals 24. The alternative is the exact opposite, so it would be not equal. And the next question asks you for the test statistic. Okay. Again, I give you the link to the website. You didn't even have to go out and look for it. Okay, so we're going to open it. And here's where a lot of you make a mistake. We talked about those guys right here. Notice you need the population variance, not the population standard deviation. Okay, so the population mean, which comes from the hypothesis, is 24. The population variance, and I'm going to go back to the question here and point this out. The last sentence here says, assume the population standard deviation is 0.55. Guys, that's that standard deviation. To get the variance, you have to square it. So you need to do 6.5 squared. So 6.5 squared is 42.25. Okay, that's how value should be entered into the website, because it asks for the population variance. Okay. So I should enter 42.25. The sample mean stated in the problem was 2.992. The sample size was 50. My significance level was 0.05, and because it has not equal in the alternative, it is a two-tailed test. So then I calculate. If we scroll to the bottom, it gives us our z value as negative 1.17489, and the p value is 2.422. Okay, so I can go back to my quiz. My test statistic was negative 1.177. My p-value, which can never be negative, by the way, is positive 0.24. Then if I make the comparison, if I go back over here to my paper, let's see, let me make you some notes here. Okay, so based on my calculator, Z is negative 1.17. P was 0.242. And I need to compare P to the alpha. Okay, so P compared to alpha. P is 0.242. Alpha is 0.05. And I'm going to make that comparison. Remember, we do it digit for digit. So 2 compared to 0. 2 is greater than 0. So P is greater than alpha. If P is greater than alpha, the rule says we fail to reject the null hypothesis. If we fail to reject the null hypothesis, let's go back up here and think what that means. If we fail to reject the null hypothesis, that means that we believe the null hypothesis is true because we fail to reject H sub O. And then by default, then the alternative is false. So if the null is true, we're saying that the average age is 24 as we believe. Okay, so we're going to fail to reject, and we believe that the average age is 24. All right, we're on the last question. Again, guys, I honestly don't know what else I could have done. It has the header there, 1 mean Z test 2, which means it's the second one, okay? And it asks which test you should conduct. Well, let me read the question first. It is believed that the average credit hours taken by GHC students is less than 13 hours. Using a 0.10 level of significance, should the findings of the class survey support the belief that the average credit hours is less than 13? The population standard deviation is 3. The sample mean credit hours for 50 randomly selected students is 11.68 hours. Okay, again, question 29. Which test should you conduct? We only talked about one of them, the 1 mean Z test. Not to mention the header said 1 mean Z test. Okay, then we got to match up the values. Okay, so 50 was our sample size. 13 is the population mean. 3 is the population standard deviation. 11.68 was the sample mean. And 0.10 was our level of significance. Okay, I'm going to go back up here and I'm going to copy the problem over into a document. Again, so we can kind of walk through it. Okay, again, it says in the first sentence, it is believed that the average credit hours taken by GHC students is less than 13. So I hope, first of all, that phrase is less than makes you think of the less than symbol mathematically. It does not seem to imply equal because it doesn't say less than or equal to or at most. So because it's less than, this statement is the alternative. The mean is less than 13, and that's the original claim. If the mean is less than 13 is the alternative, then my null would have to be that the mean is greater than or equal to 13. The other thing I'm going to point out while I'm here is that, remember, when we go to enter this into our calculator, we need the population variance. And it says the population standard deviation is 3 hours. Okay, so I know that sigma is 3. The variance, which would be sigma squared, would be 3 squared, which is 9. Okay, so I'm going back to the quiz. And again, when I go to choose my null hypothesis and alternative hypothesis, guys, if you remember that the null had to have equal in it, you had to pick the right one. And then the alternative is the opposite, which is less than. Then it says, what is the test statistic? And again, guys, I give you the link. Okay, so we open it in a new tab. Okay, so the population mean, which is in the hypothesis, was 13. You need the population variance, which we calculated to be 9. The sample mean was 11.68. It was given. We had a sample size of 50. It told us to use 0.10, so I need to change my significance level. And it was less than, which is a one-tailed test. So we calculate. And it tells us that our z value is negative 3.11127, and p is 0.00094. Okay, so I write those things down. My test statistic was negative 3.11. My test statistic was 0.00094. Going back to my page, if we compare that, if we write that down, okay, just so you have it written down, we found that z was negative 3.11, p was 0.00094. We then need to compare p to alpha. To compare p to alpha, so if I have p is 0.00094, alpha is 0.10. I'm going to make the comparison. Digit for digit. 0 compared to 1. 0 is less than 1. So p is less than or equal to alpha. The rule says we reject the null. Now, let's go back and think about what that means. If we reject the null, that means we have, based on the evidence, the null is false. Okay, which means the alternative is true. Okay, if we reject the null, the alternative is true. Okay, so we go back. We reject the null, and we have to say that it is less than 13 hours, because that was based on what, that was the statement as the alternative. Okay, that's it, guys. I can submit it. It should give me a grade. Okay, but it may benefit you to go back through and look over the questions. I really feel like a lot of you just got in a hurry and weren't paying attention to the details.